Okay, so we have another one here. So this is called the symmetric difference. So we want to put that the symmetric difference, right, is A union B minus that, right? So how do we do this? We're going to go by definition. We know by definition X will be a member of A, or X will be a member of B, and X will not be a member of A, and X will not be a member of B, right? So this is alone here. So this is the definition of a symmetric difference. Basically, if we have an element X, right? If we have an element X, it means that that element is a member of A or B, but not both. Hence, it's an element of A or B, and it is not an element of X and B at the same time, right? So from here we can then say, okay, X will be a member of, right, A union B, right, and X will not be a member of A and B, which is the intersection there. This can then be summarized as X being a member of A union B, right, intersection A intersection B complement, right? So it's not a member of this, which we can then say by De Morgan's law. We can say, okay, X is a member of A union B minus A intersection B, which is this, right? Which is what we have over here. So we say, okay, we define what the symmetric difference is, and then from that we break it down logically until we get to this point, right? So this is using again, just using the logic that we already know, the definitions and the like. Then now, how can we prove this one, right? How can we prove this one over here? So it's actually rather simple. After if you know a few rules, so basically we're going to, we know this is the same as this. So we're basically finding the cardinality of A union B, right, minus A intersection B, like that, right? So if we have that over there, we can basically split this by saying A union B, right, minus A intersection B. We can split that, right? There's a simple rule that is like that there, right? So we can easily split it like that, since we know, of course, that this is a subset, right? This is a subset of this, so we can just split it like that. Then we can say, okay, if we separate the union there, we're going to have A plus B, but when we're counting, we subtract the intersection, right? So this is just, this portion here is just from this one minus this A intersection B that we have here, right? From this point, we're going to say A plus B minus 2 A intersection B. So this is just a trivial proof for this, right? So again, what I'm saying is, we know to say, if we split it up like this, right, if we're counting elements in a union, we don't want to count the elements in the intersection twice. That's why we subtract the intersection there when we're splitting up the union, right? And we're not, if this is a subset of this, the subtraction is, we can just subtract them directly, right? As long as one is a subset of the other, which is why we just split this one in the middle, because not A union B is a subset of this one, which I'm assuming we had proved here. Yeah, we know that. Okay. Then this one, for use analytical methods, is basically this question here, right? It's basically this question, only that A is not a subset of B. So you prove it using the same thing that we've talked about. But yeah, these are the only questions I was able to find for sets. They are not a lot, I can say. Yeah, there are not that many questions I could gather that talk about how to go about solving questions for sets. But if you do have any questions, please feel free to forward them to me and I will solve them. Yeah, but that would be all for sets. Again, the variety of questions isn't that much from what I've been trying to find questions, but the variety isn't a lot. It's very staggering. Yeah. But yeah, for now, peace.